Hi there. So this talk is about end-to-end reactive programming at Netflix. My name is Jafar Husain. I'm a technical lead for the various Netflix UIs. I've got 12 years in the industry. I formerly worked at GE and Microsoft. And I've got 4 years of experience building systems with FRP. Let's rewind 2 years when I joined Netflix. Netflix had decided to change our client-server interaction model. Previously, we have a variety of different UIs that run on a variety of different devices, but they all are accessing essentially the same endpoints. And this introduced some friction for us. One, it meant tight coupling between the middle tier and the UI teams. Every single time we needed a new feature, we had to go to the UI team, they had to develop it, and then the UI could incorporate it. We also eventually got one-size-fits-all messages. As the various devices and UI platforms sort of diverged, their needs diverged, and we just sort of threw everything into the same message, and messages got larger and larger. And overall, sometimes the more a client diverged, sometimes you'd end up with inefficient call patterns. You'd make more calls, and you'd be more chatty with the server than we'd like to be. So the plan was to give UI developers the ability to create endpoints specialized for their own devices. Now, some of our UI developers saw this somewhat differently. Now, to understand the reasons for that, it's important to understand that they've got great attitudes, the UI developers. It's just, if you understand historically why this is such a difficult thing, if you were to group the two types of developers we have in Netflix, you could sort of group them in two personas. You've got your cloud developer and you have your UI developer. Now, these developers think about the world and they see things very, very differently and for obvious reasons. But even more so at Netflix, that becomes even more exaggerated. At Netflix, we deal with about 1/3 of the US broadband traffic at any given time. So we really, really scale. Those cloud developers think at scale. And yet we run on devices that are $20, $30. So UI developers have to think very, very low level. And they're very, very good at writing highly imperative code to squeeze every last bit of performance out of the device. Even though many of them are writing on JavaScript, they're often writing C-style code in JavaScript. So our challenge was, how do we turn UI developers into effective cloud developers? If we were going to turn over the reins to them to write server-side scripts, we had to make sure they could write it in a scalable way. We had to make sure that they, weren't any deadlocks, and we didn't bring down servers. So we gave them some creature comforts. We gave them Groovy, which is a JavaScript-like language some of you may be familiar with. We gave them an object-oriented API over what's really a service-oriented architecture. And we gave them a reactive API. We didn't want to introduce them to threads. So basically, we wanted something like a callback API was what we initially considered. Now, this is right around when I joined the company, and I had a slightly different approach that I'd learned at Microsoft and I wanted to apply here than callbacks. The problem really is that reactive is not enough. Wherever you have parallelism and you have data aggregation to build a JSON message, for example, you're going to have contention. And I don't trust myself to deal with locks, and I certainly don't trust JavaScript developers to deal with locks, and they shouldn't have to deal with locks. But we also want parallel programming. So how do we make parallel programming safe for UI developers? So this goes back another 2 years to the time when I was at Microsoft. I met this fellow. Some of you may have seen him before. At the time, I was working on asynchronous unit testing for Silverlight, and I was looking for some way of making that more tractable. And I ran into Eric, and he explained that he had something that he was doing around reactive programming that could make that problem a lot easier. And he asked me a question I'll never forget. What's the difference between a database query and a mouse drag event? I mean, we as developers, certainly as I as a developer, would approach these problems using very, very different programming models at the time. With a mouse drag event, if you asked me to build one, I'd build a state machine. And a database query, I'd use functional SQL-style code, right? The truth is, there's not really much difference. They're both collections. Now, that was a profound idea to me at the time, and it really changed the way that I thought about reactive programming. I'd already, was pretty darn good with map, filter, and flat map, and building programs over sequences. But it never occurred to me that I could also build programs, UI events over sequences as well. And that turned out to be fascinating. So I'm going to show you some code here, hopefully not too much code, but I will just introduce you to one little thing. Those of you may be familiar with JavaScript. In ES6, we're getting a new shorter closure function syntax. Yeah, so ES6 is going to be a heck of a lot easier to use for us functional programmers, right? So these code, now I can fit this code on a slide. So here's a query for well-rated movies. So those of you who use Netflix know that it's basically a grid of movies. We've got a list of movies, which we affectionately refer to in the company as our LOLAMO. And the query, if we want to find all of the videos that our user has rated 5, it's a relatively straightforward query. We map over each video list. And for each videos, we limit the size of the videos collection by applying a filter. And where only the rating is 5, we return it. Then we end up with a collection of collections. We flatten it into a single collection. And then we traverse it using for each. So hopefully, most of you don't have any problem with that code. But I want you to look very carefully as I transition to the code for a mouse drag event. Notice that the structure of this query is essentially the same. Well, we have three different collections here. We have mouse downs, mouse ups, and mouse moves. For every mouse down, I want to map over every mouse down, and for each of those, I'm going to return all of the mouse moves. And instead of using filter to limit the contents of that collection, I'm going to use the take until operator, which closes that collection, which ends that collection as soon as another collection fires, in this case, the mouse ups. So as you can see, and then at the end, it's just a traversal. I for each over it. I'll let this slide sink in for just a second. And in the traversal, I change state. So we see there's a fault line here between the functional code, the compositional code, and the imperative code, where I'm actually changing the state of the system. And so this brings us back to this old chestnut, right? You may remember the observer pattern and the iterator pattern from the design patterns book from way back when. There's an interesting oversight in that book. One is that there's two patterns. They talk about the iterator pattern and the observer pattern. And if you think about it, both of these patterns are really fundamentally about the same thing. They're a data producer feeding a data consumer data progressively, one piece of data at a time. The interesting thing, though, is that the iterator pattern has two semantics that are missing from the observer pattern. There's a way for the data producer to say to the consumer, I'm done, there's no more data. And there's also a way, an ambient way, thanks to throw, where the data producer can signal to the consumer that an error has happened. But when we go over to observer, we see that those two things are missing. And it seems that the folks who were writing the design patterns book were sort of focused on solving a particular problem in UI, which was UI events, where mouse moves, for example, we don't think of them as completing. We think of them just going all the time. And so they didn't really bother to add a completion semantic, nor did they bother, because again, they were thinking about UI events, where errors aren't typically what you're dealing with, of signaling away for errors. But what happens when we add those two semantics to the observer? Well, after we call on next with a piece of data, we can say at some point, we can just say on completed and say there's no more data coming out of the stream. So the producer can send to the consumer, hey, don't worry about it, there's no more data. And we can actually add an explicit callback for when an error happens. The interesting thing is, now that we've sort of completed we've completed the semantics on both sides, anything that you can do to an iterator, you can do to an observer. And the only thing that changes is the direction of the arrows. There's also, some platforms also have the notion of an iterable. Those of you familiar with Java will know this class exists. And it's basically just a way of lazily accessing an iterator, right? It's just a thunk you can pass into nothing, and out comes an iterator. Well, it turns out there is a correspondence on the observer side. There's an observable to which you can pass an observer. Finally, on some platforms, we have this notion of a disposable, a way essentially of closing off, of saying to the data producer, I'm done, I'm not iterating anymore. The .NET platform actually has this concept, but Java doesn't. And I can simply say, so that actually allows us to do some really interesting things over, for example, I/O streams, right? If I want to model an I/O stream as an iterable, the ability to be able to say, I'm done right now, you can propagate that up and you can actually close off the I/O stream. So it enables you to sort of model I/O streams as iterators, having this semantic. And we say the same semantic on the side of events. When we unhook from an event, we can think of that as just another way of saying, you know what, I'm done. I'm not interested in listening to any more data. And what Eric and his team did is they actually demonstrated that these two patterns are dual. If you go back, you can see the arguments and the coefficients, right, and how they transfer. T, return T, accept T, void, accept no arguments. This is actually huge. I mean, it's a really big deal. If you are very, very good with composition over sequences, there's now a huge number of new data sources for which with which you can play with. And Eric called this the Reactive Extensions library. He and his team at Microsoft are behind this. It's basically a combinator library for the observable type, among other things. It's open source. It's been ported to C, C#, and VB, and JavaScript, and we've actually, at Netflix, ported it to Java for our use on the server. So let's talk about it, because this is a monad, as you may have guessed right now. Essentially, it's a really rich in terms of its semantics, though, because it's actually just a rephrased continuation monad. And it's rephrased as a vector so that I can essentially get progressive bits of data again and again instead of one callback, so to speak. And I get something like null propagation semantics of the maybe monad because it's a vector. So empty propagates. Just like a list, if you apply a map to a list out and it's empty, out comes another empty. So you get sort of null propagation in that respect. and this goes back to what Dave was talking about earlier, this is really vector programming, right? And you get error propagation semantics over the either monad as well, like of the either monad. So anytime an observable errors, that's propagated up, and the behavior is very much like try-catch. So you can expect to catch that exception when you begin iterating over it, rather than having to catch it constantly at every step, as we do with callback-based programming in JavaScript. So what's interesting about this pattern is it's a very practical approach, because you have side effects at the edges. When you're producing data and pushing it onto that stream, it can be a side effectful, you can use side effects. And when you're consuming it, you can go ahead and change state. But everything in the middle is all functional composition: map, filter, reduce, merge, zip. And so it acts, as I said earlier, as a fault line between the pure and impure code. Now, it's got cancellation semantics, which I pointed out earlier, which makes it acceptable for both UI events and I/O streams. So I can do a take 5, for example, and ensure that that stream is going to get closed off under the hood. And it can be synchronous or asynchronous. People make the mistake of associating the observer pattern with asynchronicity and the iterator pattern with synchronous programming. Just because you register a callback to me doesn't mean I can't immediately fire hose data at you synchronously in that callback, and that can occasionally be very useful. So as I said earlier, cleanly abstract over I/O streams and UI events. So just to demonstrate why this type's so powerful, I'll sort of demonstrate the map function here. I want you to sort of look at how map is defined and notice that there's actually 3 types of composition going on at the same time. So if I map over an observable, I return a new observable that wraps around that the observable passed in. But at the same time, I accept an observer in the iteration function for each, and then I compose over that. I create a new observer, which just applies the projection to each item, and then passes it through. And then finally, as soon as I begin iterating, I get this subscription object back. This is the thing that you can dispose of when you're done iterating. And in this case, map's not the greatest example, because it's just a straight pass-through, right? If you unsubscribe from the underlying data source, you've unsubscribed from my translation of that data source. But in theory, if I was accepting multiple observables in an operation like zip, that subscription, I'd create a new subscription object, and in that subscription, I would dispose of both of the subscriptions from the 2 streams. Does that make sense? Okay. So, as I said, 3 types of composition, right? And so what I took away from this in my time at Microsoft and the work that I did was that we could come up with a single reactive type for both cloud and UI developers. That'll help you remember, right? So here's a big, it's a lot of code for a slide, but I've seen worse so far, so I don't feel too bad about it. Here's how we deal with social notifications on the middle tier. So this is reactive programming on the middle tier. And this is code that, very much like code a developer wrote. I obviously shortened it for the slide. But essentially, we have a problem now. We have new social features in Netflix. And you can notify your friend after you watch a movie that they should maybe watch this movie. But it's not that simple, because you might disconnect from Netflix. That video might go out of window, which is to say we might not offer it anymore by the time you look at it. So it's not it's not as easy as simply offering up those notifications. So let's take a look at this query. Here we're doing a join from all the friends in the social, for all of my friends. We're going to the message service, and we're getting all the notifications. That should accept a user too. That's my mistake. But all of my notifications. But I'm going to filter those notifications for only those videos that are available. Then we have two key selectors. One that indicates that I want to join on the friend ID, and the other that indicates I want to join on the friend ID associated with the notification. And then finally, we have a translation, like a map-like operation, where I just suck out just the data I'm interested in and return it as JSON. Does this sort of make sense to everybody? Both of these underlying services are returning observables, and they're non-blocking, and they can be executing in a parallel way. Right? I've solved this problem now in a parallel way. I've used no locks. It's completely safe. It can execute synchronously or asynchronously. The folks on the back end, the folks controlling the middle tier, can take a look at these services and actually make determinations and turn knobs and decide, you know what, I want this particular observable to execute synchronously, because overall it gives us better performance. And as the consumer, I have no notion. I don't care. Right? My programming model stays the same. And so I might consume that notification data and do a search over it. And here's an example of how we do search over videos on the UI layer. This is actually how search in Netflix works. Obviously, again, shortened version. Who's done an autocomplete box before? Right. Seems like it should be an easy problem, but it actually has some surprisingly challenging elements, right? On one hand, you don't want to fire off a separate request for every single type of character is typed, right? You want to throttle on that and send one off only every now and then. And then next is you have a race condition, because just because I press A and I send off a request for it doesn't mean it's going to come back before the request I send off for A, B, right? So we got to handle that race condition. Now in the past, and I have written an autocomplete box, I built a state machine to sort of control that. And now I realize that it's not a state machine at all. It's just a collection. And so let's see what we do here. I take all the key presses, I throttle them, I flat map over that, I grab the search. Sorry, there should be a map in there where I map from key presses to whatever's in the text box right now, so imagine that's in there. And then I grab the search results, and that essentially was going to return an observable of an array, say, of that set of search results. And then I take until I limit that collection. As soon as another key is pressed, I essentially cancel that by closing the collection, by completing it. Now, I used to think about these things in a very imperative way in terms of canceling the collection and returning to a previous state, and now I realize I can think about it in a much higher level way. I'm just ending a collection. And of course, if you flatten an array of empty arrays, nothing comes out. So at the end, the flat map ensures that those empty result sets that I've canceled don't show up. And then I just iterate over them, and I accept the result set, which is an array of results, and I set it on the list box using a setItems method. Does that make sense to everybody? Need maybe a little more time taking that slide, or is it registering? Any questions at this point? So this is sort of, you look at what it looks like, the Netflix stack looks like right now. We have a data tier, and we have a middle tier, which is red on the outside, code in from the stream, and it's in pure code when we write out to an output stream, but everything in the middle is entirely pure code. Map, filter, reduce, merge, and zip, and maybe a few others. And then, but on the UI, things are actually a good deal more complicated. It's more of this banding, right, where we'll have a little bit of impure code to change UI state, but then as soon as we can, we break back into functional style. And then we consume that sequence. We might change state a little bit, but that itself might trigger another event, which brings us back into the functional style. It's been interesting sort of integrating this style into an existing UI, where there's a tremendous amount of mutable state, trying to figure out where to apply it. And I'll talk about that in just a second. So some of the wins that came out of this process is that we got RX open sourced. Previously it was just closed sourced inside Microsoft. We ported observable to Java, so you can go ahead and use RX Java. You can take a look at the Netflix implementation. We're currently using FRP on 3 different platforms, which are actually all of the UI platforms we have, as well as on the server. And we've got large sections of the UI now written in FRP style, and there's growing awareness of and competency in functional programming in general. So what were some of the challenges around this? Really those 3, evangelism, training, and performance. I would say on the technical side there was challenges, but essentially the architecture worked pretty well. The first 2 were much, much harder than actually getting this code up and working. I think coming into an environment where there was some notion of functional programming on the server, but you essentially had Java programmers on the server, and you had JavaScript programmers on the client. I wouldn't say there was a lot of knowledge of functional programming. And so evangelism was extremely key. I had to, in many ways, I think those of us who are developers, we spend a lot of time in front of our PC and we code, and I think my soft skills needed a little bit of developing, and that was a process that I went through over that 2-year period. And I got better and better at sort of describing this. Hopefully now you're really testing me. I'm trying to describe this concept in 50 minutes. I don't know how many people have picked it up, but you get better and better, of course, about distilling what you're saying, and hopefully adapting it to each person's problem, trying to explain to a UI developer why functional reactive programming matters. And we did it quite a bit on the training side, and I'll talk about that in a second. And so focus on your soft skills, really, if you really want to get functional programming adopted in your company, and you'll meet some resistance inevitably. Try and one of the ways you can essentially overcome that resistance is really on the training and hiring side. I mean, hiring is obviously longer term. We don't have we didn't take the approach of a speaker who spoke a few talks ago of simply firing all of our UI developers. So training was key, and that's important because I mean, obviously our UI developers are, as I said earlier, extremely practiced at squeezing every little ounce of performance out of WebKit, and so we had to sort of explain to them where functional reactive programming was useful, where it could be applied, and we had to demonstrate real value. If you're spearheading this, be available for support 24/7. I mean, really, you have to be. Developers are going to run into problems, and an API documentation does very, very little because you're not teaching a library, you're teaching a paradigm. And so you have to be available to drop in and sort of help out people with the problem they're facing. And developers work weird hours, so be available. I mean, this was somewhat hubris on my part, that I thought, I could teach really 3 concepts: functional programming, vector programming, and reactive programming, all to these developers at the same time. And 2 months later, we were all going to be very well versed in it. We'd all be speaking the same language. The reality is, of these, I would say vector programming, interestingly enough, and functional programming, which are closely related, turned out to be the most challenging thing. Lots of JavaScript developers out there are familiar with promises. Anybody familiar with promises? Basically, they're like observable. They're like the scalar version of an observable. They call you once. A lot of JavaScript developers already had some knowledge and intuition about promises, and they sure do like the promise library because it thinks the way they already think, which is, I'm going to do this, and I'm going to do this, and I'm going to do this. But as we saw from the autocomplete example, that's not always necessarily the right way to think about the problem as a sequential sort of set of steps. And sometimes vector programming can really provide the answer. And the nice thing is, if you teach somebody vector programming, if you teach them the vector version of that monad, well, the scalar version's easy, right? I mean, you just return one thing. And so we use observable over calls that return one value. We don't use promise library. We just use the vector library, and we don't have to deal with all the different types, and the friction that gets introduced when you're trying to convert from one type to the other. And also doubling the API side. There's lots of the combinators that exist on scalar monads also exist on vector monads, plus more. So we just skipped the problem. We didn't teach scalar. And reactive programming was more of a challenge for the developers who were Java developers on the server. That was not necessarily a model they were used to, and functional programming had to be learned there as well. Although they might be well-versed in MapReduce, they don't necessarily think about how to do it in proc. It still feels foreign to them to apply that model right there inside their Java code. So we had to sort of teach that. We've begun to look outside of UI developers for functional programming competence. We're trying to hire developers who have some UI background, but I mean, we're interested in Scala developers, we're interested in Clojure developers, we're interested in people who really can do functional programming as well. So we changed the hiring process. Flat map is a nightmare to teach. I don't know if anybody's ever tried to teach. And it's the monadic bind over observable. And first of all, it has a million different names. And it's the hardest thing to teach developers. And I'll show how we if I have time, I'll show how we actually manage to ease developers into that concept by building interactive training exercises. And so we essentially now we can scale out our training by just giving in JavaScript exercises that literally are interactive inside the web page, where they can go and they sort of get eased from imperative concepts into functional concepts. And understanding where to apply FRP in the client is still a problem for me. I'm still piecing together through now how to build UIs, where FRP makes sense, where it makes sense to sort of take existing UI patterns and get rid of them and reinvent, and how to merge that in with the existing UI infrastructure. It's really challenging, but we've seen some very, very, like the autocomplete example is a great piece. Search is a huge piece of Netflix, and it's entirely reactive right now, and it's a really great fit. Performance is going to be a problem wherever you have a tremendous amount of composition and you're running on low-end devices. So you really have to be very judicious about where you apply it, where you apply composition. We had to scale back some of our very ambitious framework on our low-end devices. And we ended up essentially turning that vector monad into a scalar monad and essentially chunking all the work. Thankfully, most of our devices are high-end and we could get away with it. But we also occasionally had to decompose, so we turn a map and a filter, and we'd essentially, instead of chaining map and filter, we'd have to sort of create an observable and manually do that work for, say, 6 or 7 steps. You could collapse into one, and that saves you from a heck of a lot of function call overhead. As I said, best applied to less chatty event streams. We managed to do it over search on low-end devices, on left, right, up, down devices like remotes, because it takes you so damn long to select another character, it wasn't a problem. But that's what I mean when I say you got to be clever, right? You're like, oh, it'll take forever to enter that. If the user interface gets better, we're screwed. So we should look into that. Also, little things that luxuries of a type unsafeness. Flat map. Every now and then, you don't know whether you're going to generate another observable inside of a flat map or just a scalar value. And having to wrap it in an observable to satisfy the type constraints can actually add quite a bit of overhead. So relaxing those type constraints we found can be a performance win on some of our low-end devices. Some resources are there. You can go to GitHub and get the latest version of Reactive. It's available for those languages I called out, and also I should have listed here for if you want the Java version, you can go to the Netflix's GitHub, and you can go to the interactive learning exercises. This address down here. You can go through all the JavaScript learning exercises and learn about it. Any questions? Data binding in RX. So we have a form of data binding in RX. We don't make the jump to the view layer yet, so we don't have templates, so we don't do that sort of declaratively at the view layer. However, we do use it to bind together many other tiers of our application before the view layer. So what we essentially do is we introduce an observable that, at first we actually tried to have both pure and impure code in one type. We had a observable value type, where it had a value property that you could access synchronously. As it went on and we got better, we realized that wasn't actually necessary. We could just do it with observable. The challenge, though, was that observable is lazy, and it's not always the right default for data binding. In fact, it's usually the wrong default for data binding. So we're thinking about creating another type that essentially still implements the interface, but does the right thing by default, which is essentially publishes the value, stores it, doesn't lazily compute it. And so we're in that transition period right now.